Hi everyone, I believe we should be live. Hi everyone, so you can just say yes if you can hear me. Cool, so we can just start. Uh, Today's question, I would say it just required some sort of ad hoc mathematical thinking. So let's read the question. It says that we are given four integers, sx, sy. Okay, sx, sy are coordinates of a point. Okay, so imagine a Cartesian plane with xy axis. So every point has x and y coordinate. So let's say there is a point, let's call it point P1, whose coordinates are sx, sy. And then there is another point whose coordinates are fx, fy. So there is second point P2 whose coordinates are fx, fy. Okay, and then we have been given a non-negative integer called as t. So t is a non-negative integer, and now what we have to do is there is an infinite 2D grid. So you can imagine you have an infinite Cartesian plane. So at the center you have 0, 0, and then you have x-axis, positive x-axis towards the right side, negative x-axis towards the left side, positive y-axis towards the upside, and negative y towards the downside. So you have infinite number of points. Okay, now this is important line. It says that each second you must move to any of the so what is the meaning of adjacent cell? So adjacent cell means the neighbors. So if you look at any point in the space, then its adjacent points are you can say east, west, north, south, which is right, left, top and down. But apart from that, you also have the four adjacent cells in the along diagonal, right? So it means that if let's say there is a point which I call I comma j, then there are multiple adjacent points to it, multiple adjacent cells to it. The one which is towards the right, it is I comma j plus 1. The one which is towards the left, that is I comma j minus 1. The one which is towards the up, I can say I minus 1 comma j, and the one which is towards bottom, it is I plus 1 comma j. Similarly, the four diagonals, right? So so the point which is let's say diagonally down towards the right side, you can probably call it something like I plus 1 comma j plus 1, right? And similarly the point which is towards which is diagonally towards the downside, towards the left, you can call it I plus 1 j minus 1, right? Similarly, there are two more points which are towards the upside, and they will be I minus 1 j plus 1 and I minus 1 j minus 1. So I'm not writing them. I believe you can understand what those points will be. So basically, if you have a point I comma j, there are going to be 8 neighbors of it, correct? Now we have to return true if we can reach fx comma fy, which is if we can reach point 2 from point 1 after exactly t seconds. So exactly t seconds, mind it, nothing less, nothing more. So if you can reach from P1 to P2 after exactly t seconds, you have to return true, otherwise you have to return false. And now this line is analogous to the explanation that I gave you, that if you have a cell I comma j, then there are 8 neighbors to it. Okay, those 8 neighbors are up, down, left, right, and the 4 diagonal ones. Now you know the question also says that you can visit the same cell several times. So when it says you can visit same cell several times, what it means is, let's say your first point P1 is 1 comma 2, and the second point is, let's say, 1 comma 3. Okay, 1 comma 2 and 1 comma 3. Now mind it, the question says that each second you must move to any of the adjacent cells. So it takes you 1 second to move from your current position to your neighbor, and your neighbor could be any of these 8 options. On top of that, you can also visit a cell again and again. And the intent of the question is to know whether you can reach from P1 to P2 after exactly t seconds. Okay, let's say this is your point P1, 1 comma 2, and this is your point P2, and the value of t is equals to 2. So what do you say? Is it possible to reach from 1 comma 2 to 1 comma 3 after 2 seconds? Yes or no? Okay, so one of you is saying yes, others? See, if the question was something like this, that hey, what is the minimum amount of time required to reach from P1 to P2, what would have been your answer? Your answer would have been 1, because in 1 second you can move from the cell 1 comma 2 to 1 comma 3, correct? Because 1 comma 3 is a cell which is lying just above 1 comma 2, correct? So you can take 1 second to go from here to there. But in the question the value of t is 2, and you have to tell me, can I move from P1 to P2 after exactly 2 seconds or not? The answer is yes. And how I can do that is, instead of directly moving from 1 2 to 1 3, which I can, what I'll do is I'll move from 1 comma 2 to the cell which is towards its right side. Now what will be the coordinate of cell which is towards the right side? I mean, if you move along the x-axis. So it will be 2 comma 2, right? So you can go from 1 comma 2 to 2 comma 2, and now from 2 comma 2 you can take a diagonal move. Do you understand that? So when I say diagonal, I mean think of the diagonally upper cell towards the left side. What will it be? It will be 1 comma 3, right? So what you can do is that you can, like you can see here, all the neighbors that I have listed down for I comma j, like I plus 1 j, and then you have I plus 1 j plus 1 then you have I plus 1 j minus 1, and so on and on. So if you take a diagonal shift from here, you will be able to reach 1 comma 3 also, right? So it means it is possible to take 2 units of time and reach from 1 comma 2 to 1 comma 3, correct? Does it make sense that how we can reach from point P1 to P2 after 2 units of time? Right? Okay, cool. So now if let's say I were to just change this question a little bit, if I were to ask you that hey, what if the value of t is 3, can you move after, can you move from P1 to P2 after 3 units of time? The answer is yes, because see, from P1 to P2 you can definitely go in 1 unit of time, right? So what you can do is you can go from P1 to P2 and then back from P2 to P1 and then again from P2 to P1 to P2, right? So basically I can say I can move from 1 comma 2 directly to 1 comma 3, and then I can come back because it is allowed to visit a cell again. So I can come back from here to here, and then I can go back to where I wanted to go. So this is a cyclic thing, so it can keep on happening in a repeated mode, I would say. So even if the value of t was 5, the answer would have been true, right? Because you can again go from 1 comma 3 to 1 comma 2 and then back from 1 comma 2 to 1 comma 3. Even if it would have been 7, the answer would have been true. So this is a pattern which I want you guys to see and clearly understand, if it is making sense. Does it make sense? Right? So I can say that for all the odd values of t, it is possible to move from p1 to p2 for all the odd values of t. Now, how about for even values? For even values, is it possible? So for even values also, it is quite possible, because we just saw that if the value of t is 2, we can perform these two transitions, first one and second one. Now, if let's say somebody says, can you do it for t equals to 4? I would say yes. Why? Because I can go back from 1, 3 to 1, 2, and then from this 1, 2, I can reach 1, 3 again. So 1, 2, 3 and 4. So for t equals to 4 also it is possible. With the same logic, for t equals to 6 also it will be possible. So you are just, oscillating. You're just oscillating. So basically it is possible for all the natural numbers. For t equals to 1 it was possible, and that implied for all the odd numbers it will be possible. For t equals to 2 it was possible, and that implied for all even numbers also it is possible. So basically, no matter what is your value of t, as long as it is positive, I can always reach from point p1 to point p2. This is a point to be taken note of. Is it making sense? Okay. Now, what if, see, t can be 0 also. I had missed that point. If t is 0, then what will be your answer? Will it be true or false? It will be false, right? Because we all found it out that the minimum amount of time required to reach from one point to another point is 1. So let's say if the minimum amount of time is known to us, if the minimum amount of time is x, now if the value of t happens to be smaller than x, if the value of t happens to be smaller than x, then we know that it will not be possible to move from p1 to p2, because this is the minimum amount of time. But if the value of t is greater than equals to x, if the value of t is greater than equals to x, in that case, can I say that, hey, it is always going to be possible? Can I say that? Just think of it. So let's say your first point is a comma b, and from a comma b you have to reach p comma q. Now you made so many transitions to reach from a comma b to p comma q. Let's say the minimum number of transitions was x, so let's say you made x transitions, and after making those you were able to reach p comma q. Now if somebody asks you one simple question that, hey, is it possible to go from a comma b to p comma q after x plus 2 transitions? Is it possible? I would say yes, it is possible for x plus 2 transitions also. Why? Because what I can do is I can just go back from here to the previous point where I came from, and then come back from there to here. So if it is possible to do it in x steps, I can also do it in x plus 2 steps. I can also do it in x plus 4 steps. I can also do it in x plus 6 steps. So basically I can do for all, right? How about x plus 1, x plus 3, x plus 5? Is it possible to do for those many number of steps also? What do you think? Just think of it. Is it possible to do for x plus 1, x plus 3, x plus 5 number of steps also? The answer is yes. If you're wondering how, let me explain. Let's say the point where you came from was p comma q minus 1. Okay. Now from here to here, how many steps would have been there? X minus 1 steps, right? Because if you are saying total number of steps from here to here is x, that means from here to here it must have been x minus 1. Now once you are here, what you can do is that instead of directly going from here to here, you can probably go up and then come down diagonally. or you can go down and come like this diagonally. So x minus 1 step still here, and then 1 step to go up, which makes it x, and 1 step to come down like that, which makes it x plus 1. So it is always possible to reach in x plus 1 steps also. Now, if it oscillates from here to, let's say, forward and forward to backward, that will be able to do in x plus 3, x plus 5, x plus 7 for all of them. So basically the point is that if you can reach in x steps, where x is the minimum number of steps required, then for all the values of t that are greater than equals to x, you can make it. This is the most important point to understand in this question. Is it making some sense? You guys can just say a quick yes or no if you get that. Right? Okay. Now everything hinges to finding the value of this, to finding the value of minimum number of steps that are needed. So tell me, if let's say you are at a point which is 1, 3, and you have to go to a point which is 5, 9. Okay, what kind of movements are the most ideal movement for you if you have to minimize the number of steps? Horizontal, vertical, or diagonal? Which kind of movement will you prefer if you have to minimize the number of steps? Horizontal, vertical, or diagonal? Diagonal. Why diagonal? See guys, if you move horizontally, let's say diagonal movement was not allowed. If diagonal movement was not allowed, only horizontal and vertical movements were allowed, which is you can either move right or left or up or down, then the number of steps would always be equal to the sum of gap between x and sum of gap between the sum of gap between x and y. So basically the answer would always have been x difference plus y difference. So x difference implies how much gap is there along the x-axis. How much gap is there along the x-axis? It is 5 minus 1, which is 4 units. And how much gap is there along the y-axis? It is 9 minus 3, which is 6. Because we all know that the motion in x and y, both of them are independent of one another, right? So the sum of gap between x and gap between y would have been answer. But now here diagonal movements are allowed, so I can say that my answer can be smaller than this. Why? Because when you move diagonally, in that case you are moving along x-axis also and you are moving along y-axis also. That makes diagonal moves much more favorable than horizontal and vertical moves, because in horizontal and vertical moves you are either minimizing your horizontal distance or vertical distance, but here you are killing both of them with the same arrow. Is it making some sense that why diagonal move is preferred compared to horizontal and vertical? Yeah. Okay. Now that we know that diagonal movements are preferred, so what we can do is, can you imagine a point 1, 3 somewhere? So let's say 1, 3 is a point on your coordinate axis, on your Cartesian plane, and you have to reach to 5, 9. Now, how long can you move diagonally? There are two options. You move diagonally as long as the x-axis of the x coordinate of both of them become equal. That is first option. Or you move diagonally as long as the y coordinate of both of them become equal. These are the two options that you have, right? So you can imagine that if 1, 3 is here, 5, 9 will be somewhere here probably, all right? So the first option is that if you're moving up, up and up, in that case what kind of thing will happen? From 1, 3 you'll go to 2, 4, right? From 2, 4 you'll go to 3 comma 5, right? And you keep moving from 3 comma 5, you go to 4 comma 6, and from 4 comma 6 you go to 5 comma 7. This is what will happen if you are moving diagonally up. So if you are moving diagonally up from 1 comma 3, you will eventually reach 5 comma 7, correct? And now you can see that 5 comma 7 and 5 comma 9, both of them have the same x coordinate. Because both of them have the same x coordinate, that means both of them are lying along the same vertical line. And if both of them are lying along the same vertical line, that means 5 comma 9 is lying just on top of this. So now I can just make 2 more moves, which is it's just as good as the difference of 9 and 7, right? Difference of 9 and 7. So 9 minus 7 is going to be 2. 2 plus the number of moves that you made here, which is equal to 1, 2, 3, 4. So 4 plus 2, 6. So one possibility for your answer is 6. And this happens when you try to get into the same vertical line as your final point. Okay, another option could have been that instead of getting into the same vertical line, you try and get into the same horizontal line. When you try and get into the same horizontal line, in that case what will happen? In that case, the number of moves may be more, may be less. So if you have to get into the same vertical line, in that case what will you do? In that case you would somehow want that the value of your y coordinate becomes equal. So if you try to make the value of your y coordinate equal, can you tell me how many moves will happen in that case? Yeah. Okay, somebody says that I am not audible. Can you hear me? You can just confirm if I'm audible or not. Is it audible? Yeah, Purva is saying yes, so I believe others should also be able to hear it. Okay, cool, great. So as I said, the first possibility was that you keep moving and somehow make your x coordinate equal. So I changed the x coordinate of my point to 5. And the second option could have been that I change the y coordinate of my point. When I try to change the y coordinate of my point, in that case my x coordinate could be something different. But in that situation, I would be lying in the same horizontal line as this. So at that point of time, whatever is the difference between this value and the new x coordinate that I have, that needs to be added to the number of steps that I already took. So that is going to be the idea, the simple idea. Okay, cool. So if I go by this idea, what I can do is, if you look at POS 1 and POS 2, these are just the two possibilities that I had, that I just illustrated here. And in my first possibility, what I have tried to do is, I have tried to make my y coordinate equal to the y coordinate of the final point. So in that case, the number of steps that I will end up taking will be equal to this, which is the absolute difference of the destination y coordinate and source y coordinate. Now in this process, my x coordinate will get changed. So I have written a method called as get new x coordinate. So you can look at it how it works. So what get new x coordinate does is, it first figures out that how much distance you have walked, because you have tried to make your y coordinates equal. So this is the distance that you would walk. Now if the value of fx is greater than equals to sx, that means that your destination is lying towards the right side. So if you have moved towards the right side, in that case your updated value of sx will be sx plus d. But on the other hand, if the x coordinate of your destination point was smaller, that means it was lying behind. If it was lying behind, that means you moved backwards. So in that case, the updated value would have been sx minus d. So this way I am getting to know the updated value of x coordinate. I have written these methods, these separate methods, for the ease of understanding, so that you can understand that whenever we are moving along a diagonal to equalize our y coordinate, how do we get to know the updated x coordinate. Now this function backs up the calculation of second variable, which is possibility 2. So in this case, if you are trying to equalize your x coordinate, then these many steps you would take, and after that the number of steps that you will take will be equal to the difference of the y coordinate of your destination point and your updated y coordinate. So your updated y coordinate is calculated in exact same manner as that, barring few differences. You can check that out. Okay. Now whatever is the minimum of this and that reflects our overall minimum. And we all know that if the value of t is greater than or equal to minimum, we want to return true, otherwise we want to return false. However, there is a catch to it, and we have to understand what that catch is. So tell me one thing. Let's say if your source and destination points both are same, let's say this is also 8, 9 and that is also 8, 9. In this case, what will be the value of minimum? What is the minimum amount of time that you would take to reach from this point to that point? The answer is 0, because you're already there. So there is no time that you would end up taking. So if it ever happens that minimum comes out to be 0, then it points to that scenario where sx and fx would be equal, sy and fy will be equal, which means both the points would be the same point. In that case, if the value of t is 1, is it not sensible to return false? The answer is yes. It is absolutely sensible to return false, because if the value of t is 1, and no matter where you go, whether you go top, down, left, right, or diagonally, wherever you go, you have already spent 1 unit of time. You have already spent 1 second. So now there is no time which is left. So this was one major edge case in this problem. Apart from this, there was nothing special about this problem, because see, even if both values are same and value of t is something else, let's say the value of t is 0, would you want to return true? Yes. If the value of t is 2, would you want to return true? Yes, because I can always go up and come down. Also, if it is 4, 6 or any other even number, it will work. Even if it is an odd number, then there are no issues, because what I can do is, if it's let's say an odd number 3, I can go left, then I can go diagonally above, and then I can come down. Left, diagonally above, down. So how many moves are there? 3 moves. So if you can do it in 3 moves, you can also do it in 5, 7, 9, 11 different moves. So if both the points are same, in that case, your answer is going to be true for all the values of t except 1. So this is the only edge case that we needed to handle. Is it clear why this was the edge case? Yeah. Yeah, all this you can make a bit concise. I have written an extra method and done all these things just for the ease of understanding. That's it. I mean, I don't really need that method, because whatever work I did there, I can have a trivial logic to back that by writing some 1 line or 2 line here. Okay, so that's it. There was nothing memory intensive or time intensive thing about this question, because if you look at it, it's just going to take order 1 amount of time as well as order 1 amount of memory. There are no for loops involved. There are no extra arrays or maps or lists that we are creating, right? Cool. So that's it. Let's meet again tomorrow with a new question. Bye and good night.